So again, welcome everyone. Thank you for coming. We are recording the session and you will be able to find it on the EPCC YouTube channel so you could watch it later, or you can refer it to someone else who might be interested in the presentation. So welcome to our Tejano virtual events. Today we are joined for a great presentation by Calvert Boyle, who's the EPCC Makerspace coordinator. So this is something new for me and I'm excited to learn more about it. So I hope y'all get comfortable, get something to drink, mute your microphones. And if you have any questions, put them in the chat box. And later on, I will be providing a link so you all can get Tejano passport points for attending the workshop today. So I hope you can relax and enjoy. And whenever you're ready, you can go ahead and begin. Thank you.
Hi, can everyone hear me?
Yes.
Okay. Trying to turn on both the mic and video. Alrighty. Perfect. So I will go ahead and start with the presentation. This is a presentation about makerspaces. Welcome to the world of makerspaces, or as I like to call it, the next evolutionary step in education. So a little bit of introduction first. My name is Calvert Boyle. I am the Makerspace coordinator here at EPCC. The Makerspace lab and myself are located on the Valverde campus in room A1512. As you can see on screen is my email and my office phone. So if there's any kind of reason you need to contact me, maybe you have questions, maybe you want to introduce Makerspaces into your classes, maybe you're interested more about our technology or about our lab, you are more than welcome to contact me at any time. So I'll wait a couple of seconds in case anyone wants to write it down or take a screenshot or something like that. So what is a makerspace? I get this question all the time. I get it a lot. A makerspace is a collaborative workspace. It can be located kind of in any kind of educational environment, maybe school, a library. It could also be like a separate public or private facility. And it's used for making, learning, and exploring and sharing different types of high technology that varies from high-tech to no-tech tools. These spaces can be open to kids, adults, entrepreneurs, and they hold a variety of making equipment. This includes, but is not limited to, 3D printings, laser cutters, CNC milling, irons, soldering, and sewing machines. So, you may have heard of makerspaces before. You may have heard about some of the other spaces that are very similar. For example, we have makerspaces, hackerspaces, and biospaces. Now, at first, they all sound very similar. They just all have space at the end, so they must mean something similar. But they are quite a bit different in different kinds of terms. So, for example, the first one is makerspaces. That's what we offer here at EPCC. It educates users by building a final product from basic parts. So, for example, if you are trying to build a robot, we give you all of the different kits and parts and whatnot, and then you can go from there. Or, say you're trying to build a computer, we'll give you all of the parts, and then you learn how the computer works through building the computer through the separate tools. Hackerspaces work very similar, but are slightly different. They educate users by breaking down a final product into its parts. So for the computer example, if this was a hackerspace, we would hand you a computer, like an older computer, and say, all right, rip it apart, and that's how you're going to learn, that's how we'll teach you how a computer works. So, it's very similar, but slightly different. Last but not least, there is something called Biospaces. This educates users on technology that requires living organisms. In the example, I show an aquaponics, type of system where you have plants and fish that kind of survive off of each other. There are different types of biospaces. Biospaces are very often just kind of referred to medical spaces. So, for example, if you are trying to 3D print skin grafts or human organs, that's what would be called a biospace. It's not just for that. That's like the really fancy ones. But often when someone's talking about a biospace, they're probably referring to something that has to deal with, creating human tissue or organs, but they can be used for, other types of instances of, learning and whatnot. So what makes a makerspace? Makerspace labs are a newer concept. They don't really have a must-have checklist. I like to say no two makerspaces are the same. For example, you could have Makerspace A, it only has 3D scanning and 3D printing, and that's kind of like what you can learn about. Makerspace B may offer sewing, laser cutting, and VR and AR, but they may not offer 3D printing. And then, Makerspace C is something that offers like a huge amount, such as 3D scanning, 3D printing, sewing, circuitry and robotics, CNC milling, laser cutting, virtual reality. It just kind of depends on which makerspace you're at. Here at the EPCC Makerspace, we offer about 9 different stations and services. I'll get into that in a minute, but we do offer a wide variety of equipment and tech. So what makes a makerspace? Why is it so special? Makerspaces focus on up-and-coming technology. You gain hands-on skills that lead to more opportunities. And unlike traditional labs, your field of study or background experience is irrelevant. So for example, you've seen or heard of like art labs. They're only open to art students, or you have seen architecture labs. They're only open to the architecture department, engineering labs, so on and so forth. And it has been discouraging in the past to be like, oh, I really want to get into 3D printing, but I can't have access to any other equipment or tools or any other knowledge just because I'm not part of that specific department. So I can't go to that lab. We never want that. We always want to encourage people to, take advantage of all this different types of technologies, learn about it. It will be very useful in life, especially since a lot of these are becoming more and more common in practice, not in just like industrial places, but also in, regular jobs. So, you could be from the engineering, art, or architecture departments, but you could also be from the history department. You could be from the English department, philosophy, food, culinary arts department. It does not matter what department you are from, and it doesn't matter if you've heard about, let's say 3D printing 5 minutes ago, or you've been using the technology for 10 years. We are always here to help you on your educational journey. Okay, so I'm going to go through a few examples of real life applications. The first one we will start off with is medical. More specifically prosthetics, and this takes a huge advantage of 3D printing. I mean, it's not the only station that could be used in medical practices, but just for these examples. For the first one, you see a cute little chicken. Her story is that she got frozen to her bed when it was like one super harsh winter. And so in order to get her unstuck, they unfortunately had to amputate most of her legs, and so she was like very depressed and she couldn't really move around, and the owner was very afraid that she wouldn't survive. So what she did is that she actually taught a class, and so she challenged all of her students to try and make little legs for her chicken, and so those are the prosthetics that ended up working the best. So as you can see, that's one way to put them. The next two examples are for humans. For the first example, there was a guy who, had a prosthetic leg from the hospital, but, he's like, it's super, uncomfortable. It's really kind of difficult to walk in. I definitely do not like the style because, they all kind of look the same, but, he was like, I want to go for something cooler. So he just built himself a whole titanium leg. And the best thing about 3D printers is that, like, while usually 3D printers are used with plastic, there are other types of materials you can work with. There's food 3D printers. There is metal 3D printers. You've got the plastic resin types. There's even, like I said, in the Biospaces, the 3D printers that deal with human skin and human cells. So, there's a huge variety. So, he had decided to use one of the metal printers to 3D print himself a titanium leg, which I find absolutely fascinating and absolutely magnificent. Last but not least, we have a hand that has a bit of circuitry and robotics built into it. So this was supposed to be built for kids of lower income families who couldn't necessarily afford the prosthetics from the hospitals. I talked to one family that I had helped, with their own 3D printed hand, and they were like, yeah, it's going to cost like $100,000 for just one hand. And the kid was like 7. So, just for him, for temporarily, it's going to cost $100,000. I cannot imagine how many he would have to go through, still growing up and whatnot, and how much the cost would be. And so, she's just like, we really want something, but we just cannot afford the hospital one, which I was like, I feel you. I wouldn't be able to afford that either. So the one in the example is slightly different than the one that I had worked on, but it's still the same concept. For the one in the picture, it was built for someone who had their not only their hand, but kind of up to the top of their arm chopped off and whatnot. So they were using electronics to try and get the fingers to move individually and whatnot. So that is one example, of prosthetics with a bit of circuitry and robotics. Real life applications, virtual reality and architecture and art. Virtual AR and VR, or augmented reality and virtual reality, is an up and coming technology. A lot of people are into it. Augmented reality is, I don't know how often y'all use the Amazon mobile app, but if you see a piece of furniture, they're like, hold up your phone to see if the furniture fits within your space or something along those lines. That's AR, where you have the virtual piece, but you can see it in the real life background, so it's like half virtual reality. And then virtual reality is like total submersion. You have those big headsets. Well, not necessarily big, they're actually becoming way more compact, but you have the headsets or a type of glasses. You can't see anything outside the world, and you just have your one spot where you kind of look around and work with different types of realities and whatnot. So for the first example, it was used by architecture students. They had a city that was pre-built, and so the professor had said, all right, you have this one spot that you can build a building in, here are your schematics and everything, so let's see what you can come up with, and then one spot that's already built, like a city's built around it. So that was really creative and great, and students did a lot of different things with it. Second, you have and this is what I was talking about, augmented reality, where you have this is from a library, it's a planetary book, where you could scan the book and it would show, a virtual image of that planet and kind of, the different forces around it. But also at the same time, you can actually see the book there. So for the first picture, I know the person is kind of showing, but the whole point was just to show the person in virtual reality, but you can see them wearing the headset and kind of moving with the remote. But the second one is augmented reality. They probably used a phone or a tablet to scan a code that was in the book, and then the image of the model would show up. Last but not least, we have the virtual reality for art. People will do really crazy things with art. I mean, you've seen all the different art online that is just like 2D. So just imagine what people could do with like 3D art. A very common example is sculptures. For art exhibits, people have done like a lot of like 3-dimensional sculptures, and even some paintings where like at first it looks 2D, but then like when you walk closer, you can actually walk between the layers. Say it's like, a lady laying in grass or something. You've got the one layer of grass, the one layer of the lady, and then the sky and whatnot. So you can walk in between those layers to kind of see more precise of what the artist had done with those different types of layers and how the perspective had kind of changed depending on like where you're standing at. But this one is like a really cool dragon and whatnot. I tried to do art one time, and it is so much harder to do art in 3D than it is in 2D. I just was not prepared, and I didn't do well on that. But a lot of people have taken advantage of it and done like a lot of great things with it. So the dragon is kind of one example that people have done with it. Another example is a CNC milling in architecture and engineering. The very first image is actually a photo that was taken here at the lab. We have a CNC milling machine. It's a very massive machine. And so, we had put it on the bed, and we had actually taken some schematics of some furniture. One of the professors here at EPCC, her name is Crystal Lindstrom. She's part of the architecture department. She had helped create this sort of 3-dimensional furniture that you could put together without any hardware and without any glue. And so she had, designed all of the pieces to fit like a 8x4 piece of stock wood. And then you could just cut out all the parts and then just stick them together, and you have, your model of the one on the table is a cabinet, but she has built things like podiums and desks and tables. So you can do a lot with it. The second picture is kind of like a more close-up on the computer of how a CNC milling works. CNC milling is a form of subtractive manufacturing. You have your either sheet of material or block of material, and you slowly carve away at it to get your final product. So you can kind of see up close how the CNC mill is slowly carving away at the metal to make those gear teeth. And then the third picture is kind of like that same image, but in real life. I mean, it's a different part, but still, you can see the CNC mill is cutting out metal, you know, and it's like a mix between a saw and a drill bit, you know, slowly carving away until they have their final product, which was supposed to be some like engine piece. I can't remember what, but that was supposed to be the final product. Here at the EPCC Makerspace, we do have a mission statement. Our mission of the EPCC Makerspace is to offer a collaboration space for students and faculty. The space will provide tools, resources, training, and entrepreneurial opportunities pursued by its participants. And, you know, it says participants, we call them users. And this can be anyone from EPCC, you know, whether you're a student, faculty, staff, administration, everyone is welcome here. You do have to be a part of EPCC, so as long as you got that EPCC ID, you're good to go. And they can vary kind of any campus. You know, I can't bring the lab to other campuses, but they can come here, you know, whether you're from the Mission campus, the Rio Grande campus, you know, all that kind of shebang. You can come to the Valverde campus and kind of check out our technology and learn all about it, you know, anytime that you want. So the stations and services that we offer here at the EPCC Makerspace, we divide them up into two rooms. You have the clean room and then you have the dirty room. So for the clean room, we have 3D scanning, 3D printing, sewing, circuitry and robotics, soldering, and Legos. You know, so all the different types of technology. 3D scanning is where you take a physical item and you scan it in order to get that item into a 3D model. Some people will do like clay sculptures. If they make a clay sculpture, they don't necessarily want to recreate the entire item in a 3D modeling program, especially if they're not used to 3D modeling programs. So you can kind of set it on a bed, scan your sculpture from different angles and whatnot, and then have your 3D model of it. For 3D printing is a form of additive manufacturing. So that means that you have a clean bed and then you have a nozzle that will extrude material and it will build layer by layer until you have your final product. Next, we have sewing. Everyone knows what sewing is. It's kind of like, you know, most of the sewing machines are going to be like the machines you find at grandma's house, but they do also have like heavy duty machines. We hope to get an embroidery machine soon. So if anyone wants or is interested in making embroidery for blankets or pillowcases, that is an option. Or what you could do with embroidery is make patches for your jackets. So look forward to that. Circuitry and robotics is pretty self-explanatory. You know, we focus on circuits and robotics. This could be anything like robotic cars to, you know, circuit boards. If you're trying to build like an LED light timer, you know, that could be one thing. Different types of things and whatnot. Soldering is, you know, very similar to circuitry and robotics. This is how you put circuitry and robotics together. In some cases, you use soldering, so we do have the soldering station. And then Legos. Everyone knows what Legos is. And I could just hear you wondering, Calvert, why on earth would you have Legos in an up-and-coming technology lab? Well, one, they're fun, but two, they're actually very useful depending on the type of technology that you're trying to look into. A very, very popular example we have here at the lab is architecture students. If they are, you know, in the architecture field, they use a program called Rhino 3D. It is a 3D modeling program, but it is absolutely not user-friendly at all. And so what people will do is, you know, these are programs that you have to take like semester-long classes in order to learn. And so while they're still learning these programs, there's like a billion buttons, you know, it takes you like 6 hours to make like 2 cubes or something along those lines. And they have to build these like massive sculptures or buildings depending on what class they're taking. So we would advise them to come in and use the Lego sets to kind of build whatever the model they're trying to get their end goal to, whether it's, you know, a statue kind of sculpture thing, or if it's a building, you know, get it exactly how you want it, take pictures, and then model it from that pictures. That way, you don't spend 6 hours on a building, decide you don't like an entire section, so delete it, and now you've just wasted 2 to 3 hours on something that you ended up hating and deleting. So, you know, it kind of saves you a lot of time and energy. Next, we have the dirty room. Our dirty room consists of CNC milling, laser cutting and engraving, and wood shop. The wood shop is very large. We have everything from hand tools to portable electrical equipment, such as like hand drills, circular saw, jigsaws, palm routers. I could list off the entire thing, but there's a lot. And then also stationary equipment, your chop saw, scroll saw, bandsaw, table saw. We're very enthusiastic about our saws, bench grinder, belt and disc sander, drill press, all that kind of good shebang. And whatnot. So, you know, the wood shop is there is a lot to it. CNC milling, I kind of talked about a little bit earlier. You know, it's a form of subtractive manufacturing where you engrave or cut away out of a sheet of material. Laser cutting and engraving is very similar to where you have a sheet of material and you either engrave or cut away from it, you know, but it uses, you know, it can use different types of materials. You can engrave into glass, you know, cut into acrylic that maybe the CNC milling is just not, you know, either it's like way too powerful or not capable of handling, you know, it's not you advised to cut like CNC mill glass just because that would get like glass shards everywhere. So you would use something like a laser cutter and engraver for that. So a little bit about the lab, some basic information. Our hours are Monday to Friday, 8 a.m. to 5 p.m. It's just basic working hours. You can come in at any time. You can set up appointments or you can just do walk-ins. We're, you know, available for everything. Our location is at the Valverde campus, Building A, room 1512, like I said earlier. The general Makerspace email is makerspace@epcc.edu. So if you need to email us with any kind of general questions, you can use that email instead. If you're looking for very like specific technology, you know, you can email me, or if you're interested in integrating the Makerspace into your class, such as faculty consultations or something along those lines, you can email me. But if you email me with very general questions, there may be a time where I'm super busy and staff would be able to get to you a whole lot faster. So I would advise, you know, trying the Makerspace email or trying my own email type ordeal. The office phone is the same as my phone, and then the cost. Now, this is the best part. Currently, everything at the EPCC Makerspace lab is free for the EPCC community. So if you have that little ID, whether you're staff, faculty, or students, you are more than welcome to come and not only learn about our technology, but build stuff with our technology. You know, if you want to build a circuit board, that's something that you can take home. You don't have to take it apart and give it back to us. Like, all those components are for you and to go home. If you want to 3D print a sculpture or a building, or, you know, just like a little tabletop knickknack for your desk, you know, that is completely free right now. So we just ask that you don't abuse the power, but yes, everything is free. So that's something, that's a positive. You don't have to worry about cost right now. We do also offer a variety of workshops. For example, Welcome to the World of Makerspaces, the one that I am teaching right now, is one of our options. We have the 3D printing 101 basics, 3D modeling 101 basics, the safety training level green. You know, we have a good amount of different workshops that we offer right now, but you know, as time continues, a lot more will be added. So if you're interested in a certain workshop and you don't see it listed available right now, you know, either you can email me and say like, hey, I'd love to see this, or I'd love to see that, like a workshop on it. I can look into it and, you know, I can build something, and eventually we'll have this like ginormous list of workshops that we can offer. But right now we're just starting out with like a small few. So I definitely check it out and see if there's a workshop you're interested in. And speaking of Makerspace safety, we do emphasize a ton on lab safety. I know education is supposed to be the most important thing that we focus on, but you know, I mainly focus on safety. That's like my #1 priority. Education is a close second, like 1.5 or 1.25, but safety is first. We do have a safety manual and different types of safety training. We also have the safety training level green, yellow, and red, because that's what all of our equipment is divided up to, and it's into those 3 levels. So we do offer that if you want to take it online. And then we have liabilities, of course. So, you know, just to keep ourselves safe and to keep y'all safe, you know, just go ahead, you would sign the liability form and you'd be good to go. Faculty requests and class integration. I do get this asked quite a bit. There is a kind of a small step kind of process, 3-step process in order to integrate the Makerspace into your class. Maybe you want me to come to your class, one day and teach a workshop on Makerspaces or on a specific technology that we offer. Maybe you want to hold the workshop in the lab, say make a 2-hour reservation so your class could learn about 3D modeling, and then use that second hour to kind of ask myself and the staff any kind of questions that they have during that time about 3D modeling. So we do offer that too. The first step is consultations. Consultations are a must. They are required. You can't just suddenly come to me and be like, hey, my class is here and we want a 3D modeling class, because I do have a very busy schedule. I am in charge of a lot of different things. And so if you don't come to me beforehand and have a consultation with me, there is a high chance that I won't be able to promise you like what you were expecting, just because like there was no coordination between us. So for consultations, you do contact the Makerspace coordinator. Faculty consultations you can also sign up for on our My EPCC page, which I'll talk about that in a bit, but we do have online consultations that you can kind of sign up for, and you can either come in person or we could do it online. Just kind of message me or let me know, whatever's most comfortable for you. I'd highly recommend you come to the Makerspace lab so you can kind of see it in person, but I understand that, with the pandemic and whatnot, some people may still not be comfortable with that, so we do accommodate. Second is the scheduling. Oh, I should probably note too, consultations are only an hour, so it's not like I'm going to take you for half of the day. It's just one quick hour and we're good to go. Scheduling. So we have semester schedules versus single reservations. If you want to do, a couple of workshops within a semester over certain times, we can talk about that, or you can do like one single reservation. Semester schedules usually come in handy if you're trying to work on like a 3D modeling project that's going to be like a final project, or single reservations if you're just trying to introduce your kids into the technology and whatnot. We do offer that. You must be present during the workshop. You cannot just drop off your kids and peace out on me. That is not okay. You do have to be there the entire time. So if you reserve a 2-hour workshop, you need to be there in that lab, watching over your kids for the 2 hours. We are in the process of working on requests for extended lab hours. We do understand that the usual 8 to 5 sometimes doesn't work out for people, so we are working on extended hours for the lab. If you're interested in something like that, you can talk to me. We don't have anything kind of set in stone right now, but in case you're interested, you can come talk to me about that. Last but not least is the official reservation. We kind of reserve stuff in slots and in block hours. So, it's mainly a 2-hour block that you can reserve depending on what workshop you're doing. If it's just the 1 hour, you can just do the 1 hour, but usually we can cut it off into 2 hours, for reservation slots. You have a maximum of 3 reservations you can make per class per semester. So if it is fall 2021, you can make, you're teaching Art 1301, you can make 3 reservations for that class. If you're teaching Art 1302, you can make, another 3 reservations for that class. We mainly put a limit on how many workshops you can kind of sign up for the Makerspace, just because we don't want someone coming to me at the beginning of the semester, say, before the semester starts in August, and they're like, hey, I want to reserve the lab from 1 till 3 or 1 till 5 every Monday, and they up not using the lab every Monday. They only use it half the time or a quarter of the time, and that can cause issue, because when you reserve a station for your class, that is dedicated to your class. But if you reserve a station and I'm expecting you to come in, I have to turn other people down, and then if you don't come in, it just means that other people missed out on the opportunity to use that station. So that's kind of why we introduced that. We do have strict occupancy limits just because of COVID and everything. We can supply about a 30-person class per workshop and whatnot. Now, if you have to split up your class for any reason into 2 classes, say you were like, well, I have a 30-person class, but I need to split it up into 2 15 groups, that would, both of them combined would count as 1 reservation. So it's not like, oh, I have 3 reservations, but just for the first one alone, in order to accommodate 30 students, I have to, take up 2 slots. No, that still counts as 1 slot. So you're still good on that end. It's slightly confusing to kind of explain in person, but I can better explain it, through email or whatnot, or maybe even if you come in person, we can talk about it more. I could better kind of explain the reservation kind of schedule that we have. So projects that or research that has been made at the Makerspace, we have been helping out people ever since 2020. The pandemic hit us all really hard, but the Makerspace has been here hard at work since then. For example, first example is History 1302, U.S. history since 1877. I had a history professor come to me and say, hey, I am really interested in 3D printing. I'm teaching a class on, different types of history. Can we set something up? And so we were able to do that. The first image of the star pendant, well, it's supposed to be kind of like one of those awards that you get for military. It's supposed to do something with the Vietnam War. It was like, create your own medal if you were giving out medals to, war heroes and whatnot. So that was the first one. The second one was slightly different. It was a model of an Aztec, temple and whatnot. So, we can 3D print different types of things. Second example is Math 1314, pre-calculus. One of the professors had assigned a project to her students where they essentially create their own roller coaster using calculus. And so not only did they have to chart everything out and kind of put it on a poster, but they got the opportunity to 3D print their model in the 3D print their roller coaster model in the end. So as you can see on the kind of like the lower picture, that person's 3D kind of roller coaster ride, and they got to print it out. In terms of projects, we have partnered, the EPCC Makerspace did partner with a group called Fighting Against COVID. During the pandemic, we started in April. We didn't really like pause or anything. We're like, okay, this needs to happen, so we're gonna help out. And we started our whole shindig and project back in April of 2020. But we ended up printing a ton of different types of PPE for people. There was a huge mask shortage and a face shield shortage. So we ended up printing out a ton of different masks and shields for them. We also printed out ear savers, which are essentially bands that you kind of put at the back of your head, and it has different hooks depending on like what size you need. And so instead of putting your mask around your ears, wearing it for 12 hours and then your ears being super irritated, you could just extend them just slightly further and put them around the hooks on the ear mask, so that way you could save your ears from all of that rubbing all day long. A lot of nurses were excited about that. They were just like, oh, our ears are killing us, and so we were able to pass those out. And the best part about the masks models that we had used is that you could take a normal mask, so one of those regular blue or white masks that has the type of like fabric cloth kind of material. It's kind of hard to explain, but you could cut that up into 4 to 6 different squares depending on what size of a mask you used. And so you could, instead of using a mask one time and then having to toss it, you could essentially get like 4 times or 6 times the use out of it. You could wash the mask after you were done with the day, and then just pop in a new filter or a new square of that mask, and then go the next day. So you were good on that front. I know a lot of doctors and nurses were really thankful for it. We had supplied people in the local El Paso and Juarez community, but we had also gone to other communities. Some were in New York, some were in other parts of Mexico. So we were able to help quite a few people, and we were really excited about that, to kind of do our part for the community. Next was the laptop mirrors. This was very handy for faculty. You are teaching a class on the computer, and some classes are just not that easy to teach on the computer. For example, mathematics. It involves a ton of equations that you can only, unless you have a touch screen, they're kind of hard to create with a mouse. So what teachers would do is they would order one of these laptop mirrors. We would print them out, slap a mirror on it, and then we would give it to them so that it would reflect whatever their webcam saw down to their keypad. So if they had like a little tray or board, they could set over their keypad, and then they could just start writing out or drawing out what they wanted to show to the class. So that was another thing that a lot of people like to take advantage of, which we still have plenty of both. We do have plenty of 3D printed PPE and plenty of laptop mirrors. So if you're interested, it's all free. Just contact me or contact the lab, and we'll set you up with one. So how to join and get started with us. Before accessing the Makerspace, you have to do 3 steps, just 3 steps. One is to sign a liability form. We have both minor and adult in both Spanish and English, so we can accommodate all different types of people, but you just accept the one that applies to you and object to the rest. But you'll go ahead and sign the liability form just so that we know we have your permission, everything's all good and clean to go. Oh, okay. I can answer questions after I'm done with the presentation in just a minute. But yes, I can answer your question. For the, you do have to complete the Makerspace Basic Safety Workshop. It's the level green workshop. It just teaches you about the safety. A lot of it's very basic stuff, like don't run around in the lab, and like don't run around with scissors, and don't, spill a drink on the machine, like very basic stuff like that, but you do have to get through it. It takes about 30 minutes to get through the PowerPoint and quiz, about depending on how, long you take it. So it's very simple, very basic. And then you have to show us your EPCC ID. So once you've done those 3 steps, you are good to go. All of our training materials are available on our My EPCC Makerspace webpage. So you just go into your My EPCC account, click on services, scroll down near the bottom, click on Makerspace. It's the bottom left column. Click on Makerspace, and then it'll bring you to all of our different types of materials, how you can join, important links. That's the one where if you want to do a faculty consultation, or you want to reserve, a tour for your class, or, for different types of things, you can book a tour. And other types of websites that would be important depending on what station you're using. We have a list of our workshops and events, where they're at, when they're usually, held in our lab, but, the different types of workshops and, what dates and times they're available. Our documents, things like the equipment list, safety, FAQs, additional documents. Safety is where the level green safety training is posted. So you can it's posted 24/7. That way you don't have to wait for me to teach, because there's no way I could teach like enough classes to kind of adhere to everyone. So, it's just posted online. It's all online. That way, if it's 2 a.m. on a Saturday night and you are just in the mood to take it right then and right there, you can take it. Next, how to join and get started with us. If you're interested in finding out more information about like different things like 3D printing, 3D modeling, CNC milling, all of the different stations that we kind of offer here at the EPCC Makerspace, we do have a dedicated LibGuide. Just go to the search engines for the library's LibGuide, type in Makerspace, and you should be able to get to access to our page. But we have things like books, ebooks, databases, video tutorials, websites, and it is all kind of organized in order. So if you want to read a book from the library that's about 3D printing, it's all listed there. If you're interested in looking up an ebook on CNC milling, it's there. Any kind of video tutorials you want for, like, say, laser cutting, you also have that option, so on and so forth. It's all kind of broken up into different stations, so that way if you want to find something specifically, you have a place to kind of look for, and you don't have to like shift through a billion different items. And that pretty much concludes most of our workshop. The rest will be dedicated to discussion. Oh, yes, Gail was sweet enough to post the LibGuides link in the chat, so if you want to copy and paste that real quickly, you can do that. There's my contact information again, if you want to write it down or take a screenshot or anything, and I'll kind of leave that up while we go over questions. But if you have any questions or things you want to comment on, you can go ahead and ask them in the chat, and I can answer them. We do have one question so far, at least. Carlos had asked, the award plaques you made for the EPCC art show at the International Museum of Art were outstanding. How long did it take to make them? They were very fine. Thank you. Yes, there was a art show that like just opened, I want to say this past weekend, and it's at the International Museum of Art. If anyone wants to go check it out, we had made different awards for all of the contestant winners, but also just to check out people's arts. It is very amazing. The students' arts are different types of mediums and whatnot. So you can go check that out. It's a really great art show. I would recommend it. I was there and it was magnificent. But yes, we made the award plaques through laser cutting. What we had done is the people from the art gave us some sheets of acrylic. They were like the basic 8-inch by 10-inch sheets of acrylic that you can get at like Lowe's and Home Depot. And then, we stuck them in the laser cutter, set the laser cutting settings for, acrylic, and slapped on the design. The design is something that they made in like Illustrator. You can make it in other different types of mediums, but like Illustrator is just the one that they had used at the time. So they just downloaded it in a very specific file format. Is like SVG is what you use for laser cutting. And again, I go into more into detail about a lot of this in all my different workshops. But we just uploaded the SVG, placed it on the plaque, and then pressed the button and said yes, we would like to laser cut. And so we were able to cut out all the different awards. We can use an assessment at, Manny says, we can use an assessment at TM for recommendations on how to further develop or improve. Is that something you could help with? Yes, I can. I have been talking with some of the other campuses about different types of technologies that they may want to do. We have this like grand plan to have a network of makerspaces here at El Paso. Unlike other colleges, we're kind of broken apart into several different campuses. I did work at the Texas Tech Library Makerspace previously, and that was kind of just in one spot. So, and it was like the center of campus, so everyone kind of came to us. But here it's a little bit different, which is no problem at all. We will have the main lab here, and then we will also hopefully, once we can get things kind of going. The pandemic had put like a huge wrench into plans, but I've been talking to different people throughout different campuses about either incorporating a mini makerspace or maybe incorporating some of that different technology. For example, I had talked to the Trans Mountain Library people because they were interested in opening up a makerspace. So I was able to kind of help give them a game plan, different types of supplies they could use, share all the documents that I had been using with them too. Yes, I had been talking to Carlos, but I'm also, open to talking to anyone else. So if you have like a very specific department there that you want me to talk to, the head of the department or even professors, I'm more than willing or more than happy to, go up to different campuses. Rio Grande and the Northwest campus was also a couple more campuses that I was talking to, but I'm definitely open to like going everywhere. Does anyone have any more questions? Any kind of comments you would like to make?
I do. I have a question. So if someone's interested, I noticed on your website that you have classes like sewing coming up. How would you register for those?
So it's supposed to be posted online, but there may have been, if you can't find it, there may just have been an issue with submitting that to IT. So I will go ahead and double check on that. But at least if not anything, it's not like there's 100 people that are going to show up to one class. So a lot of times people will just do walk-ins, and I'll have about 10 to 12 people per workshop, especially towards the end of the semester. A lot of people are kind of hung up in class projects, so a lot of professors would like to take advantage of that, so they'll come on down for different workshops. You can always just walk in. There's supposed to be a sign up form online, but I will double check in case it's not there.
Thank you. Thank you. Does anyone else have any questions? So this was fantastic. I didn't know all of this was available to us. So really, I thank you so much for your presentation. I think it's great information, and I hope everyone takes advantage of it. So thank you again for being here today and for telling us more about the Makerspace program. So thank you.
Of course, anytime. And of course, if you want to come on down to our lab, it's located on the Valverde campus in room A1512. So you're more than welcome to come on down for a tour, to find out more about the technology, or just kind of explore the space, or maybe even learn about a few different types of things. We are always here, happy to help you on your educational journey.
Thank you. Thank you again. And I also want to thank everyone else for coming today. I hope you're enjoying this virtual workshop series. We do have a Tejano passport points in the chat, so that you are able to go with the Tejano passport program and earn a medallion for attending different events here at the college. So here's some more information on the screen about the Tejano passport program. Next week, Friday, we will be having a holiday, so we are not going to have a workshop that day. But the following week, we will have a presentation from the Sign Language Interpreter Preparation Program. So we hope that you all are able to attend. It'll be at 1 o'clock at this same place. So thank you again for being here. Hope you have a great weekend and stay safe. Thank you.